guys, what's going on? This is LeetCode number 3, longest substring without repeating characters. Before we get into the problem, let's talk about what exactly it's asking. This just asks, what is the longest substring without repeating characters? Right now, what does this mean? We need the longest, so the longest string, longest substring, which is just a continuous sequence of characters in a string without repeating characters. So a sequence that doesn't have anything like ABC or A doesn't have repeating characters, but A, B, A is an invalid substring, okay? So let's check the test cases first. Let's see. Input, I'm looking at this. Let's see, what can I find as the... Alright, so the longest substring is 3, so there's probably one of like 3 in here somewhere. Well, A, B, C, A, no. B, C, A, B, no. Okay, yeah, so it's just these first 3 characters kind of. Okay, and then here we have 4 letters, or just 1, yeah, because you can't have any repeated. And then for the third case, we have this sequence of strings, and it's just this middle 3. Okay, yeah. So I think I start to understand the problem. So how are we even gonna find if their characters are repeating? Well, if characters are repeating, that means that they already exist. So what kind of structures could tell me, are good at telling me if something already exists? Well, I know hash sets. Hash sets for one have O of 1 lookup. And so since hash sets have O of 1 lookup, what if I just added the characters from my string to a hash set and then compared to see if any were repeating? Okay, well, that could work. Well, it's an idea, right? But not really a solution. So let's come up with a brute force solution first. So how would we find the longest substring without repeating characters? So first we need to find all of the substrings without repeating characters before we find strings. Okay, well, before we find those repeating characters, we have to find all the ones as substrings. So as we covered in the last one, to find substrings is n squared. So we have n squared substrings, and then how do we find if they're repeating or not? Well, I mean, if we had all the substrings, we went over it, all of them, once, and we saw if any characters are repeating, that means it's invalid. So we could go O of n through it using a hash set, and then see where are any characters that are repeating. If any are repeating, then it's false, which means it can't be the greatest. Otherwise, we can just set the other one to true. Okay, yeah, I mean, this solution definitely works. It's a brute force, but it should work. Okay, so this simplifies to what? This simplifies to n cubed. Okay, well, it's not the best. There's probably some way to simplify it, right? So what is kind of redundant about this? What am I wasting time on? Well, I mean, I'm checking all these substrings, right, without repeating characters, but like a lot of them have repeating characters. Like in this string, for example, I mean, testing for a substring for a case like this, I mean, they're all repeating. I mean, if there's a way could I remove all the letters, maybe make them only one of each type? No. Okay, well, why don't I just try to visualize a string and see how I might pass through it? So, okay, so yeah, so this enters 3, which is just these 3, or these 3, or these 3, or these 3, and that's it. Okay, yeah, so it's just any of these 3, but how do we find that? Well, I mean, this one goes from, well, this is ABC, and it stops when it sees a letter in it. I mean, these letters in the middle almost don't even matter because, I mean, if we break this down, the longest substrings without repeating characters, inside of that string there's going to be other substrings without repeating characters. So we could slowly build up. Maybe we could do some kind of dynamic programming, right? If we took this has no repeating characters, so we could use that. And so does this, and so does this, and this. These all don't have, all the single strings, if it's just a length of 1, it won't have repeating characters. And what if we scale this? If A and B don't have any repeating characters, can we combine them? Well, if they're the same, then we can combine them, okay. Well, now I have C, so if we wanted to add C to this, we'd have to check if we can. How can we add C? Well, if this does not contain C, that means we can add it. So if it's missing, we can put it in. So let's put it in, okay? And now we have A. Well, if we compare it to what we have using our hash set, we already have A, so that won't work. So, but now what? I mean, this is the answer, right? Well, let's think of some other ways to think about this. Let's write the problem a bit differently. Let's see. B, C, B, C, B, B. So when I was defining a palindrome, I mean, a substring is just like a group, right? A lot of them has the substrings you can use like sliding windows approaches, right, with 2 pointers. So what if we try to apply that to this, right, with the idea from before? What if we started with 2 pointers here, and then we could slowly move one down the line and checking if it's repeating, right? Because, I mean, theoretically, if we could send this pointer all the way down and have no repeating characters, then it's got to work, right? But how do we tell if it's going to repeat? Well, to tell if it's going to repeat, we can just compare it to the set as we go through. So, I mean, if we were going of n through it, we wouldn't see anything at the start. So at the very beginning, if we're going of n through it, we have no information about it. As we go through this array, we could store these values into the set, right? We could, well, the first one is definitely A. I mean, A works, right? So we can add that to our set. Okay, well, we have A, so that's the longest. Length is 1, so update the longest, okay. Well, let's see if we can keep going. B here. Does my set have B? No. Okay, let's add B to the set, and let's increment it by 1. So now it's like 2. Okay, yeah, that's definitely longer. Now, what if we add another character? C, yep. C works. Now we get 3, but if only there was a way. I mean, once I reach this 4th indice, this repeats. So it repeats. So what if we could shrink the window that we're looking at? So we started looking at here and here, and slowly move this one pointer down here. But I mean, now there's duplicates, right? So what if we could shrink the string and remove this repeat? So we detect A as a duplicate. Is A contained in the set? Is contained, so we can go back to this A and we can increment by 1 and remove this element from the set. So now that A is gone, and now we have a new A to put in. Oh, okay, yeah, and that's still length 3, and that's another way to find it. And that's 2 pointers, and let's check for the other test cases. Does this work? Well, I mean, it starts here and here, right? And then we go to the right, and it sees W. Okay, so let's put W in here. Now we have these two definitely not continuous. Neither of these exist in our set. P and W now exist, right? But now we have this W. And that means, I mean everything before this W, these two W's, nothing can go before it. So what if we could just slide this left pointer, what if we slide this left pointer all the way over to here? That way we don't get duplicates anymore. So if we can ensure that our string is always valid and we're testing it, this can shrink our complexity. So what does this complexity become? Well, I mean, we're only going through it once. I mean, I guess it's O of n. Looks like we have a solution. This is pretty fast too. All right, let's check it out.
All right, before we jump into implementation, let's make sure that we know what we're doing. First, we're setting a global variable that is going to count everything, and we're going to return this at the end. Then we're going to have 2 pointers that slide throughout the array, left to right, and is going to be measuring different substrings, right? It's going to be making kind of like a sliding window, and we're going to test different substrings of different lengths, and then maximize out of that. Now, how are we going to implement this, right? We need our 2 pointers. So we're going to initialize both of them at 0. That way we can slowly move and start from there. And then we have to question, what is our while loop? In what condition will this 2-pointer approach stop? And so as we're going through and we're testing letters, once we reach this last letter, it's not going to shrink anymore. So that's going to be when the loop is going to terminate. So we can go while right is right. So now we have a while loop, but how are we measuring these characters? Remember, we need a hash set. So we declare a hash set type character. And this is our while loop, right? So now we need to think, what are we checking in each indice? Every time we step, we have 2 pointers that exist on the screen. What are we checking? Well, right away, these are the same. I think we should update these. That way we're looking at 2 different things and having a string of more than length 1, because we already know 1's the max. So let's just test for all the 2 length ones. So while right is less than length, well, where is my right pointer? My right pointer is looking at a new thing that it wants to add. So if my set.contains s.car@, so if my set contains the letter at this right pointer, that means that this element cannot be added, which means that we need to remove the element that already exists. So we need to start chopping off the back of the array. We'll start removing every element before it until it's valid to add, right? So we can remove s.car@, and then we can increment our left pointer forward. If this doesn't work, what do we want to do? So if my set does not contain this element, that means, okay, this is a valid element we can add. So let's do my set.add. add the element at the right, and then increment the R pointer. Okay, that works, but now I feel like we're missing something. How are we calculating this max at each step? Well, I mean, we have this right and left pointer. I mean, I'm sure we can calculate the length through that. So what if we set the max value after each step equal to the distance between our 2 pointers, or max? So we'll just find whatever the maximum value is. If we run our approach, let's see. Our solution wasn't accepting, so we added an initial value into our hash set, and we also made a check for the length of the string. It compiles. Cool.